Hi, welcome to this video on calculating the area of composite figures. Now the composite figures section is revised in this topic. You would have done it last year, and basically a composite figure is a combination of two or more shapes put together, or it could even be a shape with a part missing from that original shape. The way we work this out is finding the areas of individual shapes and maybe adding them together, or finding the areas of individual shapes and subtracting one from another. Now it's your job to figure out if we have to add or subtract, but it's really important that we have a good understanding of our area formulas, or how to calculate the areas of other shapes or the basic shapes before we do this section. So the area of a square or a rectangle or a triangle or any of the quadrilaterals or even parts of a circle is very important to understand. Okay, this is just a basic shape that we've got here. We sometimes call it an L shape, or this particular shape has a number of ways you can calculate its area. So I want you to think about what process you might use to find the area of that plane shape. One particular method could be to divide it up into two smaller rectangles, as shown. I've labelled both those rectangles A1 and A2, so I've used a subscript 1 just to say the area of shape 1 and the area of shape 2. So the total area would be the area of shape 1 plus, or adding, the area of shape 2. We could in fact divide it up into this arrangement, and we could call the top rectangle area 1 and the bottom rectangle its area of A2. So then we could calculate A1 and then add A2. So that's another way we can do this question. We could also create a large rectangle and have the large rectangle and subtract the area of the small rectangle. So in blue we have the area of a large rectangle, and in red now I have the area of a small rectangle, and I would in fact take away the areas of each shape rather than the other two methods where we added them, because this part here is removed and that's the small rectangle. The large rectangle is in fact all of this section. So if we remove the red rectangle from the blue one, we'll in fact have the shaded area. Okay, this particular shape here is a circle, and then we got a small circle removed. Another word for that is called an annulus. So let's find the area of this particular shape correct to 1 decimal place. Now we have 1 decimal place because we're using pi, and pi is an irrational number that continues on forever and ever and ever, so we need to round it to some sort of rounding, and we've got 1 decimal place in this question. I'm going to use capital R for the big radius and little r for the little radius, so the area would be the area of the large circle and then minusing or subtracting the area of the small circle. So our calculation will be pi times 7 squared minus pi times 4 squared. I can do that on the calculator straight away. And then I'll have to round my answer. So that is a 7, which moves that that number 6 up by 1. So we got 101.7 square centimeters. Okay, I would like you to pause this video and then calculate the area of the shaded part, or the yellow part, and I want you to figure out what shapes we have, what calculations need to be taken out. Do you need to add, do you need to subtract? What you need to do is something that I'll give you a couple of minutes, and then I'll go back and figure that out with you. So pause the video and then we'll see how you went. So in fact we've got a rectangle going around here, and all of that rectangle has that white part as well. So if we remove that semicircle, we'll in fact have what's inside in yellow. So the area of a rectangle is length times breadth, and the area of a semicircle is a half of pi r squared. So because of the measurement going across here is 9, that's the diameter, the radius will in fact be 4.5. So you have to substitute 4.5 and then square it, whereas the length and the breadth would be the 17 and the 9. So substitute, and you can use your calculator to work that out. And the question says to the nearest whole square centimetre, so the nearest whole number. And we have 121 square meters. Okay, moving on. Alright, pause the video and then calculate the areas of those two shapes, and then I'll put the answer up there quite shortly. Okay, so the area of the orangish, or the orangish part here, the shaded area, is 76 square centimeters, and the bottom one has an area of 280 square millimeters. Okay guys, thanks for watching this video. If you have any questions, make sure you write them down and ask those questions in class.